Okay, so before we can validly run our regression model, or at least rely on the results, we do need to test for that final assumption for linear regression, which is homoscedasticity. So if you read the chapter or saw our nice picture in the chapter, you can see what homoscedasticity means is that variance, here we go, there we go, variance of our data is the same along the entire line of fit. So see how the scatter plot here, let's say these are two variables, and where they land on the scatter plot, they land evenly all along the entire range of x values. So the variance in y along x here is the same everywhere. So violations of homoscedasticity, which we call heteroscedasticity, take several shapes. It can look like this, where it's wide, then it gets small, then it's wide, or it's wide up here and small back there, or it could be the reverse of this, where it starts small, then gets wide. Anyway, we need to test for that. So let's do that right now with our data. First thing we need to do is run a regression model. So let's go ahead and I'm going to kill some of these I used previously in the other videos. Let's predict purchase bike based on these variables, just like we did before. So data analysis, regression, okay, y input range right here, purchase bike. I've got labels, x input range. We're going to go to home ownership, over to marital status and down. There we go. This is the important part. Well, besides picking some place to put it, obviously, let's put it right here. What I needed to do is make sure you check residuals. What this is going to do is show you exactly what the prediction is for every case. So here's our regression. We've looked at this before. Here's our residual output. So for observation 1, this means record 1 in our data set. This one right here, person 19147. Our prediction for that person, whoops, is right here. We're predicting a 0.496731, which we would interpret as it's closer to 0, therefore we're going to predict that they won't purchase a bike. So that person actually didn't purchase a bike. That was correct, but our prediction here was 0.49673 away from that prediction of 0. So that's the residual, the leftover between what our prediction was and what actually happened. So what we need to do, because some of these are negative and some are positive, we need to start by calculating a residual squared. Oh, I've got caps lock on. Residual 2, we'll call it, equals this number raised to the 2. Awesome. Double click the lower right corner to copy it down. There's our squared residuals. Next step is we're going to copy this variable back into the data set and use it in another regression model. So what I'm going to do right here, I'll stick it right here, insert. I'm going to grab this residual squared, copy that. Now, the cases are listed here in the same order that they show up in the data, so I'm safe to just come here and hit, whoops, not that, Control V and paste that. It's rounding. Let's just so you can see that it didn't change the numbers. Let's add some, change that to number. Oh, it did automatically change them there. Oh, that's why I need to copy paste values. Let me try that one more time. Paste, special, text. There we go. So now what I want to do is predict these values. Oh, by the way, I didn't even tell you this. And by the way, this is called the Breusch-Pagan test. So what we do now is come here to data, another analysis, another regression. This time, however, we're going to use the squared residuals as our prediction. All right, output, let's pick a different spot so we can save everything. I no longer need these residuals. Okay. All right, here's what we're looking for now. The only thing we care about when we predict the squared residuals is this number right here. Was the overall ANOVA significant? In this case, it's not, which means that we cannot say that there is heteroscedasticity. We want this to not be significant. In other words, it's safe to assume that we've met the assumption of homoscedasticity. So another way to visually look at this is actually to come here and plot the original prediction against the residuals Trying to get back up. Let's see if is this going to work? Yep, it is. Okay. I'm going to select these two columns. Back up. Come on. All right, let's insert a scatter plot on that.